So just before we start connecting the board from that stop rail to the lighted stop controller or lighted rocker controller, I thought we'd just take a very quick overview look at what the connections are on this controller and how things work. So along the bottom here we've got 3 lots of matrix inputs. So it's matrix A, matrix B, matrix C. Each one caters for up to 16 rocker tabs, giving us a total of 48, hence the name of the board. And then along the top we've got our 3 lots of LED outputs. So it's fairly straightforward. The matrix is 16 rows by 2 columns, so all 3 of them are the same. So just to see how this works, if for example we connect column 1 to input 1, then we get a note on number 0, and then when we connect the same column 1 to input 2, we get note off note off 0, sorry. And then that works all the way along in pairs, so it's on, off, on, off, on, off. So the last one, if we connect 15 we get it on, and 16 we get off, so that's 0 to 7. And then if we do the same again with column 2, attach that to number 1, we get number 8 on, number 2 8 off, and so on up to 15 is 15 on, and 16 is 15 off. And then it just carries on with the next matrix. So if we do the same on matrix B, column 1 to row 1, we get note on 16 because that's stop number 16. So that will be this LED output here will now be lit. And then to switch that off again, so if we do row 1 to column 2 on the matrix B, then that switches that off. So that's how it works all the way along. So we need now to connect these matrix inputs up to our stop or rocker controller board out of the stop controller that we've been working on, and we need to connect up the LED outputs to it as well. So there are actually 3 of those boards on the stop rail, as you'll remember. So the first board is going to connect to this matrix and use these LED outputs, the second board to this one, and the third board to that one. Obviously there aren't 16 stops in each board, but that doesn't matter because it will just use up to the number that we need, and that'll carry on from there. So that's pretty much it really. I've just got this jacked up on this piece of wood simply just to avoid the reflections, because without it seems to reflect the light quite badly. So there we are. That's the stop controller interface, and we'll go now and wire it up to our stop board. Okay, so we're ready to start wiring up our matrix now. So I've got the stop controller here with the matrix inputs along the left at the bottom, which is quite hard to see because the light reflects off of this quite badly, but there we are. That's a bit easier. So we've got our row inputs 1 through 16 here, and then columns 1 and 2, and that's for our first matrix, which will be for this first board. So on this board here, our rows are going to be these diodes. So we're starting from number 1, number 2, number 3, number 4, and it goes all the way up to 22. So we've only got 16 rows, so we're going to stop at 16, and then 17, 18, 19, 20 and so on will just repeat, and that's as per this little diagram that we had previously. So as we see on here, we got rows 1 to 16, and then we repeat the same rows 1, 2, 3, 4, 5, 6. We haven't got 7 and 8 because we've only got 11 stops, and that's onto column 2. So that's what I'm going to do now. Now when these things are installed in the organ, they sit more or less next to each other like that. So obviously this board will be up at an angle on the stop rail, and this is going to be kind of almost flat behind it like that. So what I'm going to do is I'm going to make a little loom of wires that kind of go all the way round and back like that, and then that will make sure that we've got plenty of cable length to get everything to fit nicely together. So that's the next thing to do, and I shall start that now. Okay, so we've connected 16 rows now to these 16 diodes, but obviously we've still got 246 diodes left. So what we're going to do with these, as per our little drawing that we did before, so that's our 246 diodes that are left. So these are just going to start again. So this is going to be row 1, row 2, row 3, row 4, row 5 and row 6, which obviously are these here. So there are two ways I could do this. I could just connect them across on this board, but I've put heat shrink on the diodes that I've had to lift away from the board, so connecting to those would be quite tricky because I'd need to pull that back, get two wires down it and then shrink it and so on. So I don't think that's going to be the best way. Secondly, I could connect to the back of the board. The only problem is the lifted diodes are on the front of the board, so again that doesn't work. And actually, pardon me, just in case anybody's wondering why I didn't simply solder these to the back of the board, bearing in mind that this is going to be put into the wooden stop rail, so we're going to have to bring these wires out somewhere. The reason is, again, these lifted diodes. So I suppose I could have put some on the back and some on the front, but there's not really much point, I don't think. So what I'm going to do is I'm going to run a wire from the first diode here. It's going to fool around with all of these and just go back and connect onto this number 1 pad here, and the same 2, 3, 4, 5 and 6. So that's how we're going to do that. So let's carry on. Okay, so that's completed all the rows wiring, 1 through 16, and I've heat shrunk these little bits of stuff on here, just so that if these do move around on their wires, there's no danger of them shorting out to the diode next door, and it just makes it a little bit neater and stronger as well. So what I'm going to do now, I'll put a couple of cable ties on this bunch of wires just to neaten it up a little bit temporarily, but then we can flip the board over and we can look at what we're going to do with the columns. So as we said earlier in the video, we've got 1, 2, 3, 4, 5, 6, 7 connected together on one column. Let me just find the little bit of paper that we had. So we've got 7 connected together on columns 1 and 2. So what we need to do is extend that to be 16 effectively. So we're going to have to fiddle around with these columns on here. So what we're going to have is column 1 is going to be on this side and this side, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 on column 1. So we're going to have to make all of these switches, this side of them, the outer part, the inner part on this side and the outer part on this side, so that the side on both nearest this side of the board. We've got to connect all those together so that we've got the first 8 stops, if you want, connected on that one column, and then the further 3, 9, 10 and 11, we're going to connect those together to make that our column 2. So effectively what we're doing on our drawing here is column 1 and 2 existing, we're going to connect those together, and we're going to connect these together, but we're going to break it here, and then we're going to connect these together. So this will be our column 2, and this end will be our column 1. Okay, so that's how that's going to work. So that's what I'm going to do next, is just do that on the new board here, and then obviously we'll bring them across and we'll connect them to our columns 1 and 2 down here on the controller board. Okay, what I'm doing here, I'm just cutting this printed circuit board track. So you can see that these two are connected together, and this is between stops 8 and 9. So we need to cut this track away because, as we've just said, this is going to be on a second common. So we've got to cut this and we've got to join that to that. We can do that easy enough with a bit of wire, but to cut this track, it's actually quite a strong track. It's quite an old circuit board. It's got a date on it somewhere actually, March 1993. So whether they used slightly thicker copper traces then, I don't know, but I'm just using a scalpel just to kind of nibble away at it, cut away at it. It doesn't matter if it marks the actual fibre board underneath. In fact, this isn't even glass fibre, this is the old SRBP, synthetic resin bonded paper. But as long as I just cut away enough copper to make certain that that's no longer connected, which I think that's now done. Let's just check. So yeah, that looks fine, and we just check it with a meter to make double sure. So no, that's now open circuit, so that's fine. I'll just do the same this side. I marked it, don't know if it shows, yes it does on there, just with a little bit of red so that I know exactly where I'm cutting, because it would be a bit of a disaster if I cut it in the wrong place. But we just do the same again. So what I normally do to do this is just make like a bit like a sort of deep incision, if you like, either side of our red line. But as I say, this stuff is quite strong. The modern circuit boards would just fall apart if you did this. Well, the circuit board wouldn't because they're fiberglass, but the actual tracks on them nowadays would just fail pretty much straight away. Anyway, so having done that, we then just kind of scrape away at it, the idea being to break the bond between the copper and the substrate, and then just try and get the copper to come away between the two cuts that we made. So there we are. That looks good. Double check it. Still a bit left in the middle. Yep, that looks better. So we just check it with the meter again like we did on the last one. That's fine. So there we are. That's how we do that bit. So I'm going to join these here and here now, and here and here, and then join them across, so that will make our common, or column 1 if you want. And then likewise here I'm going to join these across. I think they're already connected to each other, so they are, and oops, sorry, wrong side. Yeah, they are. So I'll just join those across, and that will give us our column 2, and then that is the matrix completed. We can then test it and make sure that it all works according to plan. So let's carry on and do that. Okay, so as I said at the beginning of this operation, these two boards are going to sit next to each other. So that was going to be sort of standing up. These wires are going to come down like that, and then they're going to come along like this, and then this board is going to sit just to the right of it. So we've got plenty of spare cable, which is always a good thing, because you can always lose a bit of spare cable, but if they're not long enough, you're in trouble. So that's going to sit like that. So these two, what shall I do with them? I could take them along to join this, and actually I think that's probably going to be the neatest way. That's going to be the nicest way to do it. So that's what I'm going to do. So I'll put another cable tie here just to hold all that together, and then I'm going to bring these two. These are our common lines now, A and B, 1 and 2 columns, columns, call them what you will. So they're going to come round to here. So I'll just tidy this up, solder those on, and then we'll see if it works. Okay, so I've got this connected to the controller now. Obviously the lights aren't connected yet, but this is connected to the controller, as we can see. I'm recording the screen from that as well, so we can see now that if I press this one we get note on 0, channel 8, and if I press that end we get note off, and likewise 7, 6, 5, 4, 3, 2, 1, 0, whatever. Actually they're the other way around, aren't they? And this one without its rocker on the end's number 10. So that turns them all on, and then obviously the other side turns them all off again. So that all works, as we can see from the computer screen. So what we need to do now is connect up our LED outputs to the inputs of these transistors, which we said earlier is going to be these resistors, and then that should be it. These should light up and work and send MIDI and everything, just as they're doing now, and then we can look at the next board. We've got this bits and pieces to take care of, the transpose control and the sliders and so on, these LEDs, but they're actually going to be connected to a different board, because obviously the lighted rocker tabs controller or interface only works with lighted rocker tabs. So these bits are going to be connected to one of the other boards. The crescendo lights are going to come off the auxiliary board, the sliders are going to go to the analog inputs, and the transposer, I'm not sure yet, may take that off onto the auxiliary board along with these, or I might just take it off of the one of the straightforward keyboard interfaces. Yeah, we'll see. We'll figure out what to do with that later on. But anyway, for now, let's get these LEDs connected, or connected to these transistors. We'll put our 12 volts on here again so we can see if the lights come on, and hopefully everything works. Okay, so what I'm going to do for the wires for the LEDs, I'm going to connect them to this side of the board. The reason being that all of those resistors, these LED resistors, let's just move that out of the way, are kind of spread out quite widely across the board. We don't really want loads of wires that we don't need to have wandering about on this side of the board. So as it happens, if we remember, these LEDs along here, or these resistors, were connected back to the chip that was in here, and that chip controlled obviously the first however 8 stops I think it was, and then the last 3 were controlled by this chip over here. So what we can do, if we flip the board over, you can see the bottom of where those chips were, and we can just trace out the connections from these chips across to the LEDs, which means that we can connect all our wires just simply around that chip and this chip. So there's 3 on this chip, which I've already marked as 1, 2 and 3, and then the rest of them are on this chip. So we just need to get our meter and work out which resistors, which LEDs go to which points on the chip. So I've made a little drawing of the 2 chips here. So if we just take the first one, which as I say I've already marked, but that point there goes to the first resistor, so that's 1, and the next one 2, and the next one 3. So if I find a pen, okay, so we know it's on the bottom of this chip, and it's the 3rd, that's number 1, 4th, 2 and 5th connection is number 3. And then on this chip we can just do the same thing. So number 4, again I've already figured that out, that comes to here. So we can see that's the 3rd one in on this chip, so that's number 4. And the next one, hopefully, is 5, which it is. And the next one, where are we? 6. And the next one, 7. And the next one actually goes off that way, so it's not going to be it. Let's come back to this side then. See if we carry on at 8. So where were we? 4, 5, 6, 7. Which one is it? None of those. That one. There we are. Okay, so that's the second one in. Goes to number 8. third one in, hopefully. Goes to number 9. Fourth one in, goes to number 10. And the fifth one in, goes to number 11. So, there we are. That makes it nice and easy now to just do these wires. We can bring them from here around through our little loom here and then back to this board. And I think what I'll do, let's move it so we can see it, I think what I'll do is they'll be coming in with these wires here, so I'll just make them a little bit longer and bring them up and connect them in. Well, we're starting at number 1 this end, so connect them from there, bring them across and down them into this loom here. I think that's going to be the neatest way of doing it, so that's what we're going to do now. Okay, so we've got all the LEDs drives connected now, and obviously all the matrix connected as per previously. So what should happen now is that when we switch one of these on, the lamp should light up, and in the case of this one it doesn't, but we'll come back to that. So we press the others and the lamps come on. Hopefully you can kind of see them just about, that they come on. And the end one, and if you look at the computer screen, you can see that it says sent note on for all the various ones that are on, and the MIDI's been received as well. That's on the left hand side. So if we turn them all off again, you'll see the note offs as well, including that one. Now, as happens from time to time, and this is one of them, this bulb on the end, which is why the cover's not on it, because I took it off because we needed to check it. This bulb has actually died, which is rather unfortunate. So if we switch the meter to resistance and we put it across this bulb, so that end works, but this end there's nothing there and it doesn't light up. Now that's a bit of a challenge because these bulbs, looking on the internet, I've just done a Google search for them, don't seem to be available anywhere for love nor money. So what do we do next is the question. Ordinarily, I'm just checking to see if there's any number on it or anything, which there isn't. It says 12 volt 1 watt, and they're 20 millimeters long, these bulbs, and all the ones I can find on the internet are 31 millimeters long or 32 or something, so clearly they won't fit. So I don't really like incandescent bulbs in these things for this very reason, that when they fail, you've got to try and find a new bulb that will fit. And some of the other makes, they use these tiny little soldering bulbs, and I've got one of those here, which you can probably maybe just about see if the camera's focused on it. Hopefully you can see that, but that thing is tiny. So if we can't get a replacement bulb, then we could replace this with an LED and a resistor, but that's kind of never really going to match the colour temperature of all the others, so it's going to look slightly odd. So we could take all of these out and replace them with LEDs, but I'm not sure how well that's going to work, to be honest. It works fine with the small, you know, when they use these tiny little bulbs, because an LED is about the same size, but for these I'm not sure that that's really a good option. So I think what I'm going to do with this is I'm going to take one of these little tiny bulbs, and I'm going to take this bulb and I'm going to solder that bulb across this bulb, and I'm just going to pop it in like that, and we'll see what that looks like. Hopefully that's going to work, because I can't really think what else to do with it, to be honest. As I say, I could change them all to LEDs, but that's just going to give us little, yeah, I don't know. and also if we do that, then we won't require all of this, so we'll have to rewire all of this again, or rework it at least. So yeah, I think the next thing then, well, I'll solder that bulb across this light, across this lamp. We'll pop that in and we'll see what that looks like. So, bulb is installed, and with any luck it will work. It does. Okay, so if we put that on there, so just the right way up would be nice, so we can see what it looks like, and we turn that on. It's quite a bit brighter than the others. You can see that. So the next plan, I guess, will be to increase the value of the resistor here and just try and bring the brightness of that bulb down a little bit. It's a 12 volt bulb, but clearly it's more than 1 watt, or at least it's drawing more than 1 watt. So a little bit of experimentation required. I'll get on with that and we'll come back when we've got it balanced about right. Okay, so I've fitted a new resistor in here now. Ended up at 150 ohms, so these others are 15 ohms, this is 150 ohms, so that's 10 times more. However, if we now turn that on, that looks a lot more reasonable. If we compare it to the one at the other end, the original bulb, it's still slightly whiter, but brightness is about the same, and it's not too bad. So if we put this cover on it now, it's really hard to see in the light, but if we turn on the one next to it, there's not a huge difference. Slightly, as I say, slightly whiter, but otherwise it's okay. The resistor is, I've spaced it off the board a little bit just in case it gets a little bit warm, because obviously being such a higher resistance, there's going to be more power dissipated in it. But I've just done a quick measurement. There's 4 volts dropped across that resistor, and if you work that out with 150 ohms, it works out 0.1 watts. So that's fine. It's a 1/4 watt resistor, and you can move that out of the way. I can hold my finger on that, and it's not even warm. So happy days, that's good. That's going to be the fix for that one. So I think we've pretty much achieved what we were setting out to do. I'm going to put the fit this cap back on, fit that one back on in a moment, and then turn the lights off so that we can see it, and check that check the MIDI coming from it as well. And that's it then, really, I think, for this part. The next thing I will do is this same modification to the other 2 boards, which obviously will connect to these other 2 sets of inputs and outputs here. I won't bother filming that because we'll be here forever, or you will be sitting there watching it. You'll probably die of old age before I've finished getting it all done. So yeah, so that's it for this video. I'll get those done. I'll show you that when it's finished, and then before this board gets put back in, we've got to take care of connecting to these sliders and doing something with this transposer. So I'll put these caps on, have a quick look at it, and then that's that for now. Okay, so the caps are back on, and everything is complete as far as this part of it's concerned for the stops. So we should be able to see now a lot more than we could before, that switching these on, the lamps come on. There's still a bit of a problem with the reflected light, but anyway, it's pretty obvious that's working. And as you can see from the MIDI, or from the text monitor actually, it's sending or saying that notes are on and off, and you can see on the MIDI monitor here that all those notes are going on, and we can of course turn them all off and you'll see all the corresponding note offs there. Now obviously, because it's a controller that needs to control these from the computer, not just the other way round. So whilst we can turn these on and off manually here, and it sends MIDI to the computer as we've seen here, it needs to work the other way around as well. So what I can do is I can use this little keyboard here on the screen. So if I turn that one on, for example, you can see that number one's coming on. Obviously I can't keep it on because the minute I take my finger off it switches off, but 2 and 3 and 4, and obviously that works all the way along. So we know now that everything's working just fine with this bit. So we'll duplicate it for that, and then we'll have a look at that bit afterwards and go from there. So if you've stayed with it this long, well done, and thanks very much for watching this part.